All right, next up is gravimetric analysis. In gravimetric analysis, we use some kind of phase change to find a concentration. And this change phase is usually a liquid or dissolved solution to a solid, so it's usually a precipitation reaction. Not always, but most common. So let's just go ahead and jump straight into an example. So we have some type of solid, and then we know it contains some magnesium sulfate. But we don't know how much, and that's what we want to know. So we're going to take some of this solid, we're going to dissolve it in some liquid, so 0.543 grams of the sample is dissolved. And of course, magnesium sulfate is a soluble compound, so it will go into solution in water. And then excess barium nitrate is added. Think about why you want to add barium nitrate to magnesium sulfate. What's that going to do? I'll take a look at that in a second. After that happens, we end up with 0.734 grams of precipitate. And then we want to know what is the mass percent of magnesium sulfate in the solid. And then, of course, we want to think of a balanced chemical equation. So we have magnesium sulfate dissolved in our solution. We add to that some barium nitrate, which is also dissolved in solution. And then think about what that forms. That'll form barium sulfate, which if we take a look at our chart, is a precipitate. So that's our precipitation reaction, and our solid is barium sulfate. Meanwhile, while the magnesium and the nitrate stay in solution. If we think about what we want in this problem, we want the mass percent of magnesium sulfate in the solid. Right, so we want the mass percent. If we think about what that is, it's the grams of magnesium sulfate over the grams of the sample. And then, of course, times 100% to get to the final answer. If we think about our sample, we already have that mass. That's that 0.543 grams. So we can just take that number and plug it straight into the grams of sample. And then what we need to solve for is our grams of magnesium sulfate. And the way that we're going to do that is by taking how much barium sulfate we formed and then backtracking it back, right? So we have 0.74 or 734 grams of barium sulfate. We can convert that to moles using our molar mass. After that, we can use our balanced chemical equation to go back to how many magnesium sulfates that was. So for every 1 barium sulfate, we must have had originally 1 magnesium sulfate. And then, of course, we can go from moles to grams using the molar mass. So 120.366 is what Google tells me. And then we end up with 0.379 grams of magnesium sulfate. And then we just take that value and we plug it into our grams of magnesium sulfate, plug that into a calculator, and we get 69.8% magnesium sulfate. Note that this type of analysis assumes that you get a 100% yield, which isn't too crazy of an idea because precipitation reactions are relatively simple reactions, and you really shouldn't use that much yield. Cool.